analysis. And you look at our book, this is our book. If you are new, Machine Learning with Pytorch, and we are here applying machine learning. And in a couple of days, next 2 chapters, we'll now finish with basic classical machine learning, and we can start doing deep learning. Yeah, so we are moving. I think we are good. Right, so today what we'll see at the end of this session is we'll try to see, understand how we can clean data for machine to do sentiment analysis. Given a data set, how can we clean that data? We'll also understand how we can basically do some kind of future vectors from text document. So given text document, how can you build future vectors, right? Because if we want to train machine learning, we give that machine learning algorithm with some futures, and so how can we build future document from future vectors from text document, and then we can train machine learning model to do some kind of classification of given movie reviews. So let's move on and see what will be happening. So this is the kind of what we're gonna do, to do that. So what is sentiment analysis? So sentiment analysis is just like, trying to find opinion or sentiment given a text, whether that sentiment is negative or positive. But in today's chapter, we're gonna use a data set called IMDb, which is basically a data set for movie review, and it is 50,000 reviews. 25 are positive and 25 are negatives. So these are examples of the reviews, and these are the example of the sentiment. Now, the idea is, can we train machine learning model to automatically classify, given a review, to automatically say that this is positive, this is negative? That is the main idea. Right, so the first thing is we need to download the data, right? But if you already have the book, you download you can see like we already have the data set. Can you see movie data, the CSV GZ? This data set is already available in the GitHub. If you clone the repository, is there. So let's see how we can get the data. So this code is optional. It basically walks through you on how to download the data. So if you want to download some data from a website or somewhere else, you can basically use this code, but it's optional. We already have it, and we already have that one. So reprocessing the data set to convenient format. So when we download the data, it is not in convenient format that we can put it in pandas data frame. We want the data to be somehow in this format. This is the review, this is the sentiment. But the data set after downloading is not in that format. And now what he does is try to prepare the data set and put it in a data frame format. So this code does that. Basically here you can see here he asks us to install something called PyPrint, which basically if I import it here, import PyPrint. So basically this guy, what is it? It allows you, when you are doing some iteration, to show some progress bar. This is the task of this PyPrint. So here you can see, just giving you an example, for I in PyPrint, the progress bar, then I put the range, how many times I want, this is my 100, and I ask it to print this. So this is just something. So when you have a for loop or something like that, you can use PyPrint to just show like the progress bar. So that is the essence. If you read the book, you can see that he asks us to install this PyPrint, because while preparing the data, if we run this, we can see where you are preparing the data to become into the data frame. You can see like this is what is happening. Now, so this one, you can see we are using, pandas, OS, and Sing, and you can see here we have the levels, because the base part of that is ACLMB. If we go here to the data, yeah, can you see this guy? You see the data, where the data is. So the data, if you look at it, it is in different, you can read the README, how the data is being constructed. And you can see here, this is, okay, not this one. This is where the data is. Inside the training data, we have what is called post negative. Can you see that? So you can see this one is individually, it's a file. So this is a negative one review. This is another review, this is another review. When you go to the positive, this is another review, one review, another review, another review. So what the idea now is, can we pull all these reviews, this training data, can we pull them all and combine them into a single data frame? That is what this code is doing. So you can see we specify what are what we want. The positive is 1 and negative is 0. If you look at it here, if we look at them here, this you can see negative and positive. So here we say whatsoever is inside the positive is 1, whatsoever inside is negative is 0. So we are giving levels to it because inside this is only the text, right? There is nowhere it tells you this is negative, this is positive. Only the folder that tells you. So this is somehow kind of, trying to do that. So you can see here we put this progress bar. Now we declare some data frame, and now we go for inside, test inside this folder, inside all the test and you can see this is a test folder. So the folder contains training set and test set. So the training set is 25,000. The test set is 25,000. And inside each folder, we have negative and positive. We have all this one. So this is basically, a way to iterate all this inside it. And now, append, you can see that at the end of the day, we can have our data frame. So here you can see we have a single data frame. Now we pull everything there. You can see we have 5,000 reviews, right? So you can see here we have a review and now the sentiment. Now this is our data frame. Now we have sometimes you then your data, you will not be given data in this format, right? Nobody will give you data in this format. You need to write a code that will do that to sometimes you'll be given only a single CSV with the columns. So because here we were given the data in somehow nested folders, that is why we need to write some script to open the file and get the data in data share. So here we have our data frame. Now the next thing is, if you look at them here, we have 0, 1, 2, 3, 4. The data is in serial, meaning that because from 0 to 25,000 will be all positive, right? And from 25,000 to the last 25,000 will all be negative. So if we want to train machine learning model, when we give it the first one, it will all be positive. So we need to shuffle this data so that it will be a mix. Maybe the first one is positive, the next is negative. We need to shuffle the data. So that's the idea here. He talk about like how can we shuffle the data. So one thing he does, the approach is here you can see we try to find the index of the data frame. So we can see here the index data frame, that index, it tells you this is a range. This is the index. Can you see the index of data from 0 to 5,000? 50,000 because 499, and here starts from 0, meaning we have 5,000. So df.index, when you call index, it tells you it's a range. It starts from 0 and start at this and step 1. Now it means we have 50,000 stuff, right? Now, when I call this, I want to use randomize this, so I can use pandas mutate. So if I give this pandas mutate this index, it will randomize my number. So you can see here I have the first number. Now it becomes the 28 one. It randomizes the numbers, and from here it means it's 50,000 numbers, but they have been randomized in different order. So I want to put this randomization. I want to put them here. So this means that the 28921 will be the first one, and something like that. So that's the idea here. So you can see here, data frame, our data frame reindex, meaning change the index, right? This is a function on pandas called reindex that allows you to reindex or change your existing data frame index. So we pass a new index. Can you see? Because we have a new index. So we pass through this function reindex. So when we run this guy, now, as we can see here, our data frame has new index. No. So this is basically, a way in which we can shuffle our data set. Any question? And we can basically now, since our data set is now in good shape, we have a data set. This is the data set we want to. Then we can save this data set right in our folder so that we'll be using it. So you can see here I say df to CSV. I provide the data, name of the file, movie data, index, false. I don't need any index, and encoding. So we use UTF-8 encoding. Remember, this is a standard encoding, so we want to be using. So here it means we save our data frame. When I can basically, when I save it here, I can, when I run this guy, because inside the folder here, I can see here. So you can see here, I have my, this guy, you can see movie review data set. You can see it here. And yep, yep, we can see open silver shoulder. If it is too large by showing coming. All right, anyway, let's go back. Okay, so you can see here, we now load the data. We just want to load it after saving it to see whether the data is correct. So we can see we can use read CSV, and here we provide the encoding scheme, which is UTF-8, right? And now, we have this DF rename column. 0 is cost review, 1 is cost sentiment. So here you can see our data. Basically, previously it's like you can see it's review sentiment, but now here the following is necessary on some computers. Okay, maybe I think something is not working, but let me see what happened. Okay, in my computer is okay, everything, maybe in some Windows, I don't know. So maybe here he's talking about renaming some columns, but everything okay with me. So we can see here that our data frame, after saving and reading, everything is okay. So yeah, any question?
Doctor, I came late. I'm very much sorry.
Yes, go on. Can I have a question there?
So I am far away. It's very vital. This topic this chapter is very vital. I want to read this. I'm very much sorry.
So what do you want us to do?
Maybe done summary, a little bit summary in a nutshell.
Okay, yeah. So what we are doing today is, chapter 8 of this book, machine learning to sentiment analysis. And we said this thing that we are going to cover. We will be given a data set which is unclean, but we will try to clean the data, and work with that. And also we need to build future vectors from text document. So this is, obviously a data set for sentiment analysis, giving a review, classify it whether it's positive or negative or whatsoever. And we said we're gonna use data sets from what is called IMDb movie review. It's a data set for review of movies that says this movie is negative or positive. Now here we said how can we obtain the data set? So we provide this code, the book provides this code that allows you to download data. So if you want to download data from internet, this is something, but the book already provide the data, but this is optional that allow you to know how to, if you want to practice downloading, you can follow that. We also discuss about processing the data set, because the data set is not in the right format that we want to work on. So how can we process the data, put it in a single data? If we look at it, the data we said is in this format. You can see the data. It has test and trend. So if you look at the test, inside the test there is negative and positive, meaning that this negative is only one tweet, one review in each document. In this is TXT. Also here in each TXT is one review. So here in this test folder, I have 25,000 reviews. In this trend folder, I have 25,000 reviews also, which are all inside the positive and negative. So how can I match all this data set in negative, positive inside the test, and inside the negative and positive inside trend? How can I match it all to have a single data frame? So that's what this code is doing. I explained something first here that there is something called PyPrint, which allow us to, see the progress of action we are doing. So here, import PyPrint, you can see like I declare n is 100, and now for I in PyPrint progress bar, I say range how many times, I want to run this. So this allows you to show progress bar when you are doing something. So this code, as I already explained, go into this nested folder, all these guys, and now, pull them everything together, and now create a data frame with a review and sentiment. This is the data set. So this is the data set we have after doing this step that it goes into this nested folder and do that. So this is our review, this is our sentiment. And now we talk about shuffling the data frame, because we can see here the data frame here, we can see we have from 0 to 499, meaning 50,000, but the first 25,000 are positive, and then last 25,000 are negative. So meaning that if we want to train a machine learning model, we take the first maybe 20 and say we only take the positive, right? Because the last one are negative. So we need to shuffle the data.
The model will not line you.
Yes, so the data set will be like, the negative, something like that. And now we discuss about something. What is the index here? We want to shuffle this index, meaning I want to take this one maybe to bring in the first one. I want to take, second one to be, so something I need to shuffle. So we talk about how can we shuffle. So the first thing we say, let's find the index. What are the index? The data frame index, we can see it starts from 0 to 50,000. And now we said, okay, we can use a NumPy function called permute, right? And we give it the index, it will permute this one. So we can see NP, the random permutation, give this index, it permute this one. We can see like it permute it changes it from sequentially. Can we see that this is 0, 1, 2 up to this? So it changes. So it meaning that we can pass this to reindex function for in our data. So here, this is our data frame, and we say reindex, meaning change the index to what? To new index, which we created here. So here we give it to reindex it, and now here when we run this, we can see now it reindex the data frame. So we can see here it's now a bit of positive. This is positive. This is negative. Positive. It is mixed. So we can take anyway, anyhow, and it will make sure we will know that we have a sample of both positive and negative as representative in the data. And now here we said, okay, let us save the data frame. Here we can see we save it to data frame to CSV allows you to save your data frame. And here we say we have encoding, which is one of the way if you want to save, make sure you define set the encoding to UTF-8, unless sometimes your data will be corrupted, but UTF-8 is now the standard way to do some stuff. And now after saving movie review, we can see now we have our data movie review. Can we see it here? Movie review here. Now we say, okay, let's see and load the data to see that everything is okay. Now we can use pandas read CSV, right? So pandas read CSV, move the data, and we provide the encoding. And now after loading it, we want to see the data. So we can see like, yeah, so we can see that this is the
account they can interfere.
Okay. Okay. Yeah. Okay. So we can see like this is our data set. I remember here we said index equals to false, meaning that our data frame, you can see after we shuffle it, it has now index 1 this, 1 this, not like 1 2 3 4, but we want to reset it. Now when we reset it, it will now make sure that this one is now 1 2 3 in some orders. That's why here we said reset it. So when we read the file, you can see here, let me run this section. Let me save this. Okay, so you can see here now the first one here is election, but now when we save, we say index all, don't save the index. But now here you can see when we reload it, when we delete it after saving, it has now index 0 1 2, which is natural index we all want to see in our data set. We don't want to see this. We did it just for reshuffling, right? Here I copy our data frame all. I want to use it in some ways. So here we can later on, here we can see our data frame. So Shape allows you to see how many data frame you have, how many rows you have, and how many columns, meaning that now here we have 50,000 reviews and we have 2 columns. So this is, way the book presented, but this reshuffling, if we have a data frame using scikit-learn, we don't even need to reshuffle the data here, but it tells you something. But when we want to read the data to create trend test set in scikit-learn, trend test split allow us to reshuffle our data. If you remember that in our previous, do you remember this?
Yes.
Yeah. Any question before we continue?
Doctor, the reason why we shuffle here is because of the structure of the data.
Yeah, so the reason why, he wants to have the data reshuffle, meaning that if he wants to go to creating training test, because he has not used train test from that function that we use to divide data set from scikit-learn. In the later chapter, when he wants to create train set and test set, he has not used that thing. That is why he wants to just reshuffle his data from here.
Okay.
Yes, we'll see that. So any question? So that's the first thing here. What we have now is just we prepare our data set into format that we can use to train machine learning model. So the next thing is what is called vectorization, which is transforming data, transforming document into future vectors. Now, what we all know is that if you want to do machine learning, now we are dealing with text. This is a text. Your machine learning algorithm will never understand this text the way it is. What do we want to do to make sure machine learning algorithm understand this text? Who can tell us?
We need to convert it to zeros and ones.
Exactly. We need to convert this text into 0 and 1 because machine learning only understands 0 and 1. So we need to convert election into some numbers. We need to convert is into some numbers. We need to convert Chinese. That is what we call vectorization. So
different from level encoding.
You said different from
level encoding.
Right. So we talked about something previously for those that are not here that is called level encoder, right? So, and also the level encoding allows you to change your text into somehow kind of vectors, right? Word. It still is something I think is called bag of word. The level encoding is just a technique, level encoding. That does that, but the level encoding, if you remember, let me remember something. No. Level encoding, if you remember, not the level encoding, we'll see another thing. Level encoding is when you are given a data set with your features and your level. And your level, for example, are 1, 2, 3, meaning 1 is maybe black, 2 is white, 3 is green. Now, this thing, 1, 2, 3, they represent some order. If you want to train machine learning to predict this, we need to convert this into somehow or use a level encoder to turn this into some kind of format that doesn't have this. But this is somehow related to that, just converting to vectors is somehow related. But here, what we are talking about, we are not converting level, but this is a text on itself, not level. From what you are saying, level encoders, they are converting levels that we want to predict into numbers, but this is given the text. Yeah. So if you look at this here is, for example, I have this, the red dog, the cat is this, this, right? Now, if what vectorization means is that I first need to create, a dictionary of all the words that represent this document. So this is a dictionary of all these words. All these 1, 2, 3, 4, 5, these words, they are all present here. Can you see that? Now, so given a document, meaning given 5,000 document, this one, the review, 5,000, I need to create a dictionary 5,000 like this. And you know that words that repeats are not repeated. So for example, here we can see we have dog here, we have dog here, we have dog, no, here we have dog, but we only have one dog, right? So immediately create an instance of only one words, all the words from this to make a dictionary. And now here you can see here this sentence or this document, we can see like here we said do we have the in this one? Then yes, we have. Do you have red in this? Yes, we have. Do you have dog in this? Yes, we have. But everywhere where we don't have represent this word is 0, 0. What about this one? Do we have the in this? No. Do you have red? No. Do we have dog? Yes. Do you? This is one way that we call, you know, vector. Remember, if you want to train machine learning model, this is the kind of data we give the machine learning model, right? Future vector, where we have the futures on the top, and now we have some value. So this is one way to create a future vector using machine learning. But we have different kind of techniques to create this future. We have what we call bag of word. We have what we call TF-IDF. We have what is called word to bag. We have what is called glove. We have what we call fax test. All this one allow us to create a future vector. Any question before we move on? Any question? Okay, so yes, go on.
This particular one, which of the techniques did we apply?
Yes, so this is called bag of word.
Okay, the first one.
Yes, bag of. So this is the bag of what we want to go. So here in this document, I put some link here. You can see different way that you can create. So in our book, like House NLP, we talk about there is intended to present what is called word to bag, which is just trying to convert words into vector. What we mean by vector, given words, how can you represent that word into vector, into sequence of numbers? So next week, we're going to have presentation on House NLP. It will present word to vector. But at this chapter, you know, so you can represent, you can use any of this, whether back of word, TF idea, word to bag, glove, facet, to represent your text and now do sentiment analysis. But in classical machine learning, we are now using TF idea before back of word, but now in embeddings, we have what is called embeddings, which is now being used in deep learning. But we'll talk about that more. So let's look at the first one, introducing the bag of word model. So what this means, bag of word model, the first thing we need to create is create a vocabulary of unique word. So for example, given these sentences, 1, 2, 3, create a vocabulary of unique word. What are the unique words from this one? So these are the unique. Can you see them? They are unique. We construct a future vector from each document that contains the count of how often each word occurs. So you can see here, we construct this feature. So for this document, we can see like how many about we have 1, how many var do we have 5. This is what we call the count feature. You can see this, you know, this one, how many, just I explained something like this here, you know what I mean? So you can see, since the unique word in each document represent only small sorted or other word in the back of word vector, the feature vector will be what we call sparse. So you can see this is sparse, meaning that it contains a lot of zeros. Can we see that it is contain a lot of zeros? This is one of these advantage of bag of word. It is sparse matrix. It creates a sparse matrix, and sparse matrix does not contain some useful information. Yeah, so how can we do that? You know, this is just information. How can we create, you know, bag of word from automatically? So from scikit-learn, remember we have scikit-learn. We say from scikit-learn from future extraction the text, because you can see here we are extracting futures from given a text, right? So this is stored in scikit-learn the future extraction the text import what we call count vectorizer. Count vectorizer is the one that can do this job. So here you can see we create an object called count, and now here what we need to do is to give this count vectorizer something. So here you can see I create a document, an array with sentences, 3 sentences, and now after creating these 3 sentences, after creating these sentences, you know, you can see I feed this one. This is scikit-learn. You remember all this one. When we import an object, we create an object count. Now I can use this count and fit transform. I can use this function called fit transform on the document you want to create bag of word. So when I run this guy, now I create bag of word. So let's look at it. So you can see when I run this, I have my bag of word, which means here that D happens, 6, given the sun is 4, is 1, shining. So let's look at what this means, but to see it in this format. So what we can see here is we can say bag, can you see bag, this bag? This means it shows you the vocabulary underscore. It shows you the vocabularies you have, because here you can see these are the vocabularies we have. Can you see the vocabularies here? So this one, when you fit transform, you call count vocabulary. It shows you the vocabularies you have. But when you want to see it in this format, this one like this, can you see in this this one? Now you need to call bag the array. So you can see print back to the array. So you can see how it put it here. All right. So now when you look at this vocabulary, you can see for the first one here, we have 0 and. Can you see and? We have and 0, right? And at the first position, meaning that in this first position is and. In second, because you remember patterns start from 0. So what is in the second position? 1. We have what? Is, right? So is this position. Then 2. 1 is this. So let's look at it here. Now, the and in the first position, in the first document, do we have and? In the first one, we don't have and, right? Can you see here? We don't have and. Can we see we don't have and? But here also, do we have and? We can see we don't have and. But what about here? Do we have and? And can we see we have 2 and? So here we can see we have 2 representation of and. Can you see? So meaning that this is first document, that is the row, first document. Remember, this is it. First document, second document, third document. So in NLP, we call a sentence document in some way. Just a sentence, we call it a document. So this is a document, this is a document, this is a document. A document that contains many words in it, right? So you can see here in this first document, do we have and? No. Do we have in the second? No. Do we have in the third? Yes, we have 2. What about the second column? The second column we can see like is 1, right? Which is. Do we have is in the first column? Yes, we have. In the second column? Yes, we have. In the second document. In the third document, how many do we have? 1, 2, 3. We have 3. Can you see that? So this is just the way to represent your future vector. Any question? Okay, so this,
the representation is not going to be binary representation.
Yes. So this is what we call term frequency. This some way, I think this one is just like binary representation. Okay, this one is not. Oh, this one maybe what we call, yeah, this is, I think, binary representation maybe, because I can see only 0 and 1. But you can see that, of course, this is what we call term frequency, meaning term, each term it is frequency. You can see like a term frequency. This is called term frequency. Given term D, the number of times it appears. So term frequency, the number of times a term occurs in a document. The number of times a term occurs in a document. So this is one way to represent your, future vector before you give it to machine learning. So remember what we are doing, because we are dealing with text. Remember in our previous instance, we were given only sequence of numbers in a data frame, and we just go and train the machine learning model. But in text, NLP, you'll be given like text like this, and it is one of the tasks for you is to change these numbers, this text into numbers. And one approach is what we have just seen, which is called bag of word. But we have many, we'll see that. Yeah, so you can see here, the bag of word here we saw, okay. Yeah, the bag of word here we saw like, we give like only a single number, single term, right? Is, shining, weather only. But sometimes, the bag of word, the generalization is what we call n-gram model. What we mean by n-gram model is like, sometimes you don't need to create bag of, you don't need to create this model with single word. You need to create model with combination of the word. For example, here we have 1 gram. So if you're going to have 2 gram, you can see the sun. You combine this Z and sun to create one word. You combine the next sentence, next word, sun is, to create one word, and combine the next word, and this is shining. Sometimes the n-gram, bigram works better in some kind of, NLP task. What I mean, for example, let's look at this one. The phrase here, example. Okay, here, the phrase, the car is not good. So when we look at this example, the car is not good. The car is not good. If you look at this one, okay. Maybe they didn't give this example. They just use this. Let me get this one here as well. The phrase, the car is not bad. Okay, so if you look at this one, the phrase, let me put it in comma. And just leave it. So if you look at this phrase, the car is not good. We can see that this is negative, is negative, right? But if you use like only one word, because in sentiment analysis, what we try to do is, given this is a good car. So in sentiment analysis, what we try to do is we create a future, but we want to make sure that this is a good car. Okay, we can see that this is a good car can be categorized as positive, right? Because it contains the word good. But what about this? The car is not good. So you can see here it's negative, negation, right? So it is good, like we create a term with 2 terms. Then if we have not good in our dictionary, we can tell that not good is negative. Can you see that? Whereas we can say not bad, you can see it negate. You can see we can say not bad is positive. So this means that the generalization of n-gram, you can make sure like whatsoever you want. So this is unigram, but you can also use what is called n-gram, which is 2 gram or bigram. So for you to do that, when I create my vectorizer, you can see here by default it create 1 gram, but you can create 2 grams. So here you can see I can give n-gram range. I say 2 by 2. Now when I run this guy and ask it to give me, you can see the sun is shining. It has one, the sun. The next one, sun is. Can you see sun is shining? Can you see it is shining? So it creates like n-gram, but with bigram. So this is what we call bigram. And some studies, if you are doing sentiment analysis, some studies say working with n-gram, bigram sometimes is better than bigram is better than 1 gram. So it depends on, this is something, that you can work on to see which one is best. So yeah, any question? No question?
I need more explanation.
Oh, okay. Right. On which one?
On n-gram.
Okay, n-gram. So you remember here what I explained is that for you to do machine learning, you must convert your data into these vectors, right? But what we said here is this, what we see here is that we have only one word: about, bad, head, is, the, word, you. We can see this, right? And we can create this future vector. But sometimes, instead for you to use this, it is quite useful not to use only 1 gram.
Okay.
It is useful better to create maybe bigram, whatsoever gram. This means that if I have a new sentence here, I will have about the will be here, meaning that about the here, the bad here, so that's what they mean. Here you can see we create 1 gram where we have only the sun is shining and this, and we create this, which is called our by 1 gram. But there is generalization of what we call, 1 gram, which is what we call n gram. You can have bigram, 3rd gram, where it contains many grams. That is what we call n-gram models. So you can see the sequence of items in bag of word model that we just created is so-called 1 gram or unigram model. Each item or token in the vocabulary represents a single word. We can see that each item represents a single word, right? More generally, the contiguous sequence of items in NLP word later also are also called n-gram. So in NLP, continuous representation of word, whether it is 2, if it is 2, we say bigram. If it's 3, we say trigram.
I understand, I get it.
If it is 4, we say that. So why do we create bigram or 1 gram? Why do we do that? So this is some kind of hyperparameter tuning. When you are doing sentiment analysis, you can try with 1 gram and see what is the performance. You can try with bigram and see what is the performance. In fact, there are some studies that shows performance. Let's see, bigram versus unigram sentiment analysis. I want to show something that is so some time. What is this? Anyway, yeah. So you can see this is somehow kind of unigram here. You can see camera, digital, whatsoever. Bigram, we have in unigram we have 155 different words. In bigram we have 41. In trigram we have 19. So it depends on trigram, yeah, you can see this one here. They calculate something with that. So yeah, what I'm trying to say is that it depends on what you are trying to do. If you are using sentiment analysis, you can try different one and they can have different beta performance. Yeah, it's just like hyperparameter tuning we use in machine learning.
Okay.
Yeah, so we can see like this one, we have what I show, vocabulary and stuff like that. All right, any question again? Okay, so let's move on. So remember what we are doing is, I keep saying we are trying to,
Doctor,
yes, go on, Shamsuddin.
Is there any performance difference in terms of the bi and the uni and n-gram models?
Yeah, so this is what I want to show because I saw another paper. So you can see, okay. Yeah, so you can see like, let me see this one. So you can see some example here. This is a performance of machine learning. You can see with unigram, with bigrams, and trigrams. So you can see, for example, here with unigram, this is a with trigram, look at the performance. With bigram, look at the performance. In the unigram, look at the performance. I think this is not performance of machine learning. Oh, maybe this is a good one. Yeah, so this is I'm trying to find an example that shows perplexity. Yeah, this is something. Yeah, this is something that shows different accuracy using trigram, bigram. So you can see here these are some of the accuracy, with unigram, all this. So what I'm trying to say is that, of course, there is different performance. If you want to find out, train the model and use bigram. So yeah, you can see another example, unigram, bigram, trigrams. You can see like they are showing the performance, the accuracy. Yep. So yeah, definitely there will be different performance with them. Okay, any question? All right. Shamsuddin, are you okay?
Yes, I'm okay.
Okay. So yeah, you can try to Google and see. Yeah. So that's what we call, n-gram model, n-gram just represented. But this is n-gram is somehow kind of, not widely used in, machine learning, because there are some beta approach that does that. So let's look at what is called term frequency inverse document frequency, TF-IDF. TF-IDF. So what is TF-IDF? Term frequency inverse document frequency. That's what it is. There is a lot of mathematics behind it, but I'm not going further, but I will just give like the top what that means. So if you look at this, when we use the n-gram, we can see like the word is here in this position has the most occurrence in the document, right? You can see is here, is here, he is here, right? But is not useful in sentiment analysis. What is useful are some words, right? For example, sweet in sentiment may be better, right? Sweet here and, some word. So what we are trying to say, when you have document in document, words that occur quite often, they are not useful for your algorithm. They will not contribute much often, right? So this n-gram model gives words that occur quite often much weight, the representation, but we don't want this. We want words that do not occur quite often to have more represent. For example, here, shining. Shining is positive, right? Some we can say something is shining, shining is shining, something like that, or something is sweet, but we can see, the representation is not that quite good. So TF-IDF comes to that. What you can see, they are saying when we analyzing text data, we often encounter words that occur across multiple documents from both classes. This frequently occurred words typically don't contain useful information, right? Now we want to create now a representation that gives weight to words that are contain more useful information. So what this works is what we call TF-IDF, term frequency inverse document frequency. I may not go further into the mathematics. This is just TF-IDF of given term and document is just multiplication of term frequency, which is what we calculate here using count vectorizer. Count vectorizer give us term frequency because this is term frequency. The number of each item occurs, that is term frequency, times what you call IDF, inverse of term frequency. IDF is inverse of this guy. Can you see that? Inverse of it, inverse. So which is, inverse of document frequency, not term frequency, I mean document frequency, inverse of document frequency. So, and it's given by this formula. You can read the books, give more examples, even hands-on example how you can calculate that so that you make sure you understand. It gives example hands-on. But for us to calculate term frequency in this, we also have something in scikit-learn to do that, which is called TF-DIF transformer. Just at the way here we have count vectorizer that calculate 1 gram model whatsoever. Now we have here TF-IDF transformer. So this is what we use. So here we can say, because remember we are using future extraction from text, we import sklearn the future extraction the text, import TF-DIF transformer, and now here you can see we said TF-IDF transformer. Use TIDF true, yes. Use normalization. We put some normalization. This is some kind of hyperparameter tuning, and use what is called smooth IDF true. We said yes. What is the meaning of smooth here? We use 1 here that smooth. The problem is that when we have this is 0, then we say when any term is 0, then we are going to divide by 0. So 1 divided by 0 will give us infinite number, which is not divisible. So we do what we call smoothing by adding the number. So the number has 1 plus 1 on it. That is how it is. So meaning this smooth IDF true, meaning that we want to smooth it here. So that's our TF-IDF. So what are we going to do? So given any data, we can transform it. So this TF-IDF fit transform, but what it receives as input is, the frequency, term frequency from count vectorizer. So here we call count frequency transform of the document we already have. Remember, this is our document. Can you see this document? This document. So this TF-IDF fit transform, it receive count frequencies from this. So that's what. So now here you can see we have it. So you can see here we have our TF-IDF matrix. We can see here, for example, the 0 that occurs quite often, it is frequency reduced. We can see like now 0.5 here is 0. It is no longer that thing that we have 0.3. This representation, you can see that 3, So this is what we call TF-IDF. And here they make a comment. As you saw in the previous section, the word is had the largest term frequency in the third document, being the most frequently occurred word. However, after transforming the same feature vectors into TF-IDF, the word is now associated with relatively small TF-IDF, right? In the third document, since it also represents first and second. So this is the idea, given frequency to less frequency to most occurring item. Yeah, so why TF-IDF can be better representation than bag of word. So this is what we call, bag of word. The Ngram model is called bag of word, where we just have the frequency. It's called bag of word. Why is this useful is that bag of word are just create set of vectors containing the count of word, while TF-IDF model contain information on the more important word and less important one. So you can see TF-IDF has information, right? Which words are important. So words with very small, occurrence, they are less important, and word with higher stuff, they are of higher importance. So here you can see we have this one with higher importance here, but this one, so this is basically the main idea. And also the bag of word model is commonly used in method for document classification, where frequency occurrence in each word is used as this. So we still use bag of word in document classification and other stuff. Also, if you remember in bag of word, our feature matrix is somehow sparse. We can see 0, 0, 0 in it, right? A lot of zeros. This is what we call sparse. And some model may find it difficult to model. In some machine learning model, they find it difficult to perform well if your feature vector is so sparse. So that's also one disadvantage for that. So yeah, so that's about representation of your words into feature vector. Any question before we move on? Okay, so now we have to see how we can transform our text into features, right? But one thing we should know also is that we need to clean your data. When you receive a data set, if it is a text, because it's not number, it may contain garbage. It may contain a lot of other stuff that are not useful. So what we need to do is we need to clean that data so that it contains useful information. So that's bring us clean data. This is one of our paper, quality at glance. We can see the paper has been written, and one thing you should see is that at least 15 corpora have no usable text, because people now start creating corpus just from web. Now, when we manually audit this data set, it's large data set, we find out at least 15 corpora, 15 data set, they contain no useful text, useful information. What I mean by that useful, maybe they contain just some kind of, garbage. It's not data set for that corpora. So it's quite good given a data set to clean the data. So this is what this section is. So what I want to do is, like, we know our data set. We want to look at the first, one of the item, from the data. We can see here, we have one item here at the, okay, let me see, not this, let me see, okay, this one, love, okay, let me see another one, example, 70, let me see another one, 18. Okay, so what I want to do is, I want to say is that, given a data, you need to clean it. So this data set that we have for review, it contains a lot of garbage, meaning that you will see like hypertext. You can see like, some quite a lot of stuff. So you need to clean the data. So for us to clean the data, we're going to use here what is called regex, which is write a regular expression to clean text. So here we import RE, which is regular expression in Python. And now we are creating a function called preprocess. And now given anything, it will clear the text. It will, have any emoticon, and it will, replace emoticon with this stuff. So when we run this guy, given an example here, just a text, you can see we have / here. When I run this, so you can see it removed all this, / and / Can you see that? And yeah, so what I mean here is that this is regex. We don't have time to look through the regex, what it does, but I will give like a reference on what how to learn the regex the best way. So you can see the main idea I want to tell us is we need to clean our data. And now the way to clean your data is by using regex to clean your data. So here we clean that. This is another example, but I think this example is not giving me the, okay, it's not that. So here we clean this one, though it's not that difficult. So we can see this one here, it contains like, anchor tag, it contains many things. When we run, we can see it remove the anchor tag, right? Now here we can now apply, we can use apply. So we can see now we create a function called preprocessor that clean our data set, clean every sentence. So now we can apply it to the whole review column. So remember here, this is our df. This is our df, right? You can see we have this, right? So we need to clean this mess stuff, right? Now, what we can do, since we have a function preprocessor that given any single line, it can clean it. Can you see it can clean it? Now we can use a function called apply. Then we put this, it will apply on every review, everything in each column. So this one here, when we do that, then it can do that. So when we say this, we apply here. Now I can, so you can see now it's taking time. Now when can you see that it cleaned everything? Now our data is clean. So why do we need to clean? You cannot go and clean your, train your machine learning model with this rubbish because it may not learn well. There are many other things that, are there in the document, but we need to clean it. One way to clean it, as you can see, we even, lowercase everything. You can see like this is lowercase, you can see that. And this is also part of our, regex. You can see text to lower. You can see meaning change any text to lower, right? Yeah, so this is more about it. So this is clean the data. All right, so here you can see we clean the data, and now this is some more information if you want to learn regex, how to use regex to do that. Any question?
So doctor, while cleaning, we just get rid of what do I call them, punctuations? Not
yes. Yeah. So when you are doing cleaning, you can see this one, like, this is the old one. You can see here, for example, okay, let me run this guy. Okay, this is the old one. This is the old data frame that we have. You can see election. You can see now, this is it. You can see this stuff has been removed, right? You can see here, comma here. Can you see light? Can you see there is no comma here because it doesn't make add anything? I remove it. So you can remove comma, you can remove you can see this. I will like I remove even it, you can see that there are many standard way to pre-process string, but one good thing that you can do is lowercase the text, remove any like anchor, remove stop, or you remove commas, all these other things, small things, you remove them. Now it is easier for anybody given this, to make to tell us what the sentiment is there. Yeah.
Well, doctor.
Yes.
In any way, if you remove any of the words that like is or to or a,
yes,
will the data be distorted somehow?
Well, yeah. So yeah, so the reason why you are doing that is you are preparing the data for machine learning, because machine learning, you want to give it the best way to learn that data. So it's not like the data is distorted, but you are preparing it the best way the model can learn. So it's still quite useful, the data, even if you remove all this stuff, you are just preparing the data in a better way. Is that okay?
Yeah, it's okay.
Okay, so here I was trying to use GitHub Copilot to invoke code for regex. You can see regex for cleaning tweets, but it's not coming. I don't know. Pytorch regex for cleaning tweets. So this is what we call GitHub Copilot. You will you will see like it write the whole code. It can, remember I shared something our WhatsApp group where I just ask question and deep learning model, which is called GPT-3, it just writes something. So here also it doing the same thing. I don't know why now it's not working. But when I just do like this, it will just give me for cleaning tweet. So I just want to show you what is called GPT GitHub Copilot. Anyway, I don't know why it's not working. Anyway, so now we have discussed some, we want to train machine learning model to do sentiment classification, but we need to prepare the data first in the best possible way that the machine learning model can do a good job, right? So this is one way that we now discuss that we have discussed now how you can change your text into vector representation, which we have seen now using TF-IDF, which the one we go. We now move on to say, okay, we want to clean our data set, which we have seen now. The next thing we're gonna see is what we call tokenization. That is changing each and every stuff. So let's look at what we mean by that. So given a text here, runners like running and thus they run. Now, before you do your machine learning, you need to tokenize, meaning you remember okay, let me show you something like this. Remember this one we saw here? Okay, yeah, we saw this guy, right? So if we have this text, for example, you can see we are creating unique word, right? Here we create a unique word. This means that here, if there is this kind of sentence, running will be a unique word. Run will be a unique word. But running and run are one word, right? We need a way that we will change this running to its base term, because that is what we call, what do you call it? Stemming.
Stemming and lemmatization.
Stemming in some way. So changing word to its root word, right? So we need a technique. So in this way, before you create this guy, you need to stem every word, so that if you have such kind of instances, now running and run, then you have only, you need to change this one to run, so that you can say, okay, we have two run in the data. So for example, if I have loving, loves, can you see that? So you see all this word mean loved, right? So if you want to do sentiment analysis, you need to change all this to one love, maybe to unique word love. So you say that if a document contains this love, it means like it contains 4 love. So you can say it's so much positive. But this one, so that's the main idea, tokenization. So this is the main idea. But if you look at it, Python allows us to split word, right? So I have a sample here. Can you see I have this sentence? I create a function depth tokenizer, and given any text, use that text and split the text. This is Python function, whatever, split it. So now when I call this tokenizer, this function on this sentence, you can see it's split it. This. You can see running and run different, right? But this is ineffective when we want to create bag upward or TF-IDF. This is ineffective. before we create TF-IDF, we will need to make sure that we tokenize our sentence so that running and run are the same. So this is what brings us to what we call NLTK. So NLTK allow us to do a lot of other stuff. You can install NLTK with Conda or PIP. Now we have what is called POTA stemma, which is basically a stemming algorithm. There are many algorithms, POTA stemma that can stem. So here we can see from NLTK after you install POTA and import POTA stemma. So here I can create a POTA object. And now you can see here, I want to create tokenizer POTA. Now for any word in text split, return the stem word. So this is, yeah, for any word, this is a function, return this. So this is, what do you call it? List comprehension. So for any word in the text split, here we can see we split the word. For any word in text split, return the stem. It is stem. So when we run this guy, now let's call this function. This is a tokenizer function. When we run this, you can see it return run and run are now the same. So this means that this model we can see now allow us now this way allow us now to create, to change this. So don't forget, we are still preparing our text so that we make it more possible to do that. So you can see here when I'm writing something, all these run and run are the same. Any question before we move on?
Yes, sir.
Eh?
Yes, sir. What a plural word. Like
Yeah, so
part and
yeah, you see what?
the plural, singular and plural,
Okay,
like but with S.
which one?
But and but.
What is bad? Can you
Plural,
spell?
plural, B-I-R-D. And
B?
the one with S, B-I-R-D-S.
Like this?
Yeah, yeah. And
Okay.
but, yeah.
Okay, let's look at it. So you can see here, we have birds and bad. Okay. It returned differently. Can you see it works? Girls, boys, girl, boy. Yeah, so this is called POTA stemma, which stem words, yeah. So the reason why this is useful in sentiment analysis, so for example, in sentiment analysis, we use it. This is a good, this is a, bad movie. It is the baddest, right, ever I have seen. So you can see that the reason why we want to tokenize that, we want to like, we want the model to see how gravity of word are. So if we want to stem this word baddest to bad, so the model can see like this contain many bad, right? Many bad. It can give it, can say that, yes, this is negative sentence. But when it is contain baddest, the model will struggle to make connection bad, baddest, different, they are different words. But if they are contain the same word, then the model can say, bad and bad can, make sure that this is a negative sentence, something like that. So this is why it is useful to actually, stem word. Any question before we move on?
Doctor, what about irregular tenses?
Yeah. So
like run and run.
Okay. Run and what?
Run and run.
Run. Running. Okay. Muna da runs ne ko ba mu da runs? You can see that.
Okay.
Yeah. So yeah. So another thing we want to look at finally is stop word removal. So there is something called stop word in NLP. So when you want to do NLP, sometimes we remove words that are not quite useful in our stuff. So what I mean by not useful, so if I say this car is beautiful, this car is beautiful, and I love it. I love it, right? Now, we can see here, there are some words that appears, quite often in English, like is, like and, like I it. They appear quite often. Yes, of course, this is positive sentence, right? But what about if I remove all these words that appear quite often? Is, this, and, it, I. Is this positive or negative? We can still say this is positive. Can we see that? We'll still say this sentence is positive. So the idea in NLP is removal of stop word does not change the state, does not change, for example, in sentiment analysis, does not change the sentiment of stop. But for machine translation, you will not say you remove the stop word. So this kind of word that appear quite often in text, they are called stop word in NLP. And in sentiment analysis, in some way, we remove them, right? But in this context, we remove them. But when we come to deep learning, we don't even remove them, because in deep learning, it understands contextual. But this classical machine learning, we remove the stop word. Now, how can we remove stop word? Now, you can see, for example, NLTK contain list of stop word. So here you can see I download NLTK. Here I say stop word. Now I download the stop word. So NLTK is some kind of a Python package that allows you to do a lot of stuff. So I said print stop words word English. So you can see this as stop word for English. You can see IME. Stop word German. You can see that. Stop word Hausa, because Hausa is low resource. You cannot see the stop word Hausa. Can you see that? So this is our effort to see like Hausa and other low resource are being captured. So now we need to create a function that can remove all stop word from our text. So you can see here a runner like this. We can have we can have this something for that can remove that for W in tokenize this. So after you tokenize this, so here we tokenize what? If W is not a stop word, it's not stop, because you can see here I create a stop word. Stop here, meaning this is a list of words which are stop word. Now I'm trying to say that if after I tokenize, and if that what I tokenize is not a stop word, don't return it. But if it is stop word, don't return it. So when I run this, you can see here, it returns something like this. You can see here we have runner like run, but and is removed, A is removed. Can you see that? And A is removed. Right. So these are some of the bolts we take. Now we understand how to clean, tokenize, remove stop word. The next thing is to train machine learning model. So you see, like when you're dealing with text, it's all like when you are dealing with just numerical values. When you are given data frame with just numerical value, you just train your machine learning model. In NLP, you need to prepare those words. You need to prepare your text to a better way that you can do. So we will stop here, and next week we can start going and looking at how we can train the machine learning model, putting all the steps we have so you can see them. You can start going through them. I will push this one in the GitHub repository. You can start them. You can see we put everything that we do. Tokenizer, stop word, tokenize, everything, we put them. And now you can see a single line after putting everything that we show there. You can just put them, put here and train your machine learning model. You can see we train the machine learning model, and we have some kind of accuracy for prediction what is negative and something like this. But for now, we will stop here. You can go and revise what we have done. And if you have any question, you can ask before next week, then we can start. You can even train the model and try to understand everything behind the scene. Cool. Any question?